Hello students, welcome to my YouTube channel. Today my topic is center of gravity and moment of inertia. So today I will take the T sections and I will find the moment of inertia and center of gravity. So today we will discuss a very simple method, simple steps will follow. If you will watch this video 20 minutes, then you will know the 100% you will get the concept of the moment of inertia. You will feel like master. So now you see what is the questions how they will ask. Find the moment of inertia about the centroidal axis of T section. So given the dimensions, given top flange they given 180 mm and wave gap 40 mm, then bottom flange they given 80 mm, wave gap is 60 mm. So we'll start to proceed how we'll solve. So first work is we'll keep our T section is the first coordinate. Why we'll keep the first coordinate? You see this one concept I will explain. First coordinate, both x is plus, y is plus. Second coordinate, x is minus, y is plus. Third coordinate, both are negative. Fourth coordinate, x is positive, y is negative. If other coordinate, it will take a plus minus is coming. So we'll keep our given object, given body in the first coordinate. So let us start first work. So we'll take this first coordinate. So see, we'll draw this. So we made the axis. This axis is x-axis and this is y-axis. So we kept our given T sections in first coordinate. Next step number 2, we'll cut the section. How many sections looks here? 2 sections. Both are rectangle. So anyone can take section 1, anyone can take section 2. So okay, I am taking section 1, this is taking section 2. So no issue, you can take this as a section 1, this as a section 2, not a matter. So okay, now first axis of reference we assumed, then we cut the section. So okay, now both 2 sections will write the separately. So it will be easy for calculate the area, moment of inertia, all those things it will be easy to calculate. So first one is 180 mm. This is 40 mm. Next is 80 mm. Section 1. Section 2. 80 mm. This is 60 mm. Okay. Now, to calculate the center of gravity, we have to find out the middle sections of the T section. What is center of gravity? If entire body weight will act at a particular point where the entire T section's weight will concentrated, that is known as center of gravity. So if we will take the single sections, like here all 2 sections, they are all a rectangle. If we will take the single section, suppose rectangle, this is breadth and height. So what is the center of gravity? What is the center of gravity for this section? Half distance. If you measure from here, it's called x bar, half distance. This is called y bar. So what is this point? B by 2 and h by 2. B by 2 and h by 2. So this is the center of gravity, directly we can find. So half distance, if we will take horizontally x bar, vertically y bar. So we can reach the center of gravity point. That means in that rectangle, entire body weight will act at that point. This is known as center of gravity. So suppose 2 sections is there. So 2 sections is there, now one formula is there to calculate the center of gravity. See, I will write the formula A1 x1. A1 is individual section of area. X1 is individual section of center of gravity. Then total area A1 plus A2. Now y bar. Similarly A1 y1 plus A2 y2. Then total area A1 plus A2. So these two we can find out the x bar and y bar. Total center of gravity about xx, total center of gravity about yy. So what is unknown we are seeing here? Area, A1, A2. What is A1, A2? See, this taken as sections outside. So rectangle, what is area of rectangle? Length into breadth. So 180 into 40. So 7200. Area is square, mm square. Area unit is mm square. Now A2, 80 into 60. So 4800 mm square, area over. Now x1, x2, x3, x4 we have to calculate. x2, then y1, y2, x1, x2, y1, y2. So how we'll calculate the x1, x2? x1 is individual section of center of gravity. x1 is x1, x2, y1, y2 is individual section of center of gravity. Now look here. Always we'll take x1 from the y-axis. Why we'll take from y-axis? I will tell you now. And y1 will take from the x-axis. Let's understand here one simple example. This horizontal line is known as y is equal to 0 line. This line is known as x equal to 0 line. This is the origin, no? 0, 0. That is, this is y is equal to 0 line, x equal to 0 line. If we draw the x equal to 1, see, 1, 2, 3, like this. So where we are writing here, but how will represent? So see, how much distance we are measuring from the here. Suppose 2, we will see from the here. This is the distance. So that means x1, individual section of center of gravity, will take from the reference axis in y direction, y axis. Similarly, this is called y0, then y1. This is called y2. So see how we'll measure the distance y1 from the horizontal axis. From the horizontal axis. So based on this concept, now I will write now x1. One section. This section is connected to the axis of reference. So total distance is, this is nothing but 180. So 180 by 2. Because I already told center of gravity is half distance. So here half distance is center of gravity. It's equal to 90 mm. Because distance, so unit is mm. Now we take the x2. x2, now this is the section. What is thickness? 60. So we'll write 60 by 2. But it's not completed. 60. This half distance we taken. But what is this distance? We have to find out. So this we have to add. So total is 180. 180 minus 60, 120. So this 60, this also 60. So 60 add here. So this distance is 60. So 60 plus, so this 90 mm. X is 90 mm. So look here. X is our, how we taken the in x1 from the reference axis 180 by 2. From x2 60 by 2. But where is this block? After 60 mm. So we wrote. Now y1. y1. So we'll write near y1. From the x-axis. What is section 2? Section 1? 80 plus, what is the thickness? 40. 40 by 2. So 100 mm. Now y2. This only, second section. How much height? 80. So half distance 80 by 2. 80 by 2. So 40 mm. One more thing, small things you have to remember here. x1 90 directly should not write. Nothing wrong. But if you write 180 by 2, 60 plus 60 by 2, so once paper will evaluate the teacher, so they will see the steps, so they will understand clearly. Because your motto is to explain the teacher briefly. So that's why always try to write this form. Then you write final answers. Okay. Now what we'll do? We'll substitute the value in the x bar, y bar. So a1, a2 we know, x1, x2, y1, y2 we know. So this x bar value you will get 90 mm. How I know this 90 mm? I will tell you now. Directly I know the 90 mm. x1 also 90, x2 also 90, this also 90. Why? So you see this. We'll see the symmetry of this section. So symmetric sections, how will know? If we'll cut the sections either horizontally, either vertically or horizontally, we'll see which way we can cut these sections equal. Suppose we'll draw the vertical line. Now you see we are able to cut both sections equally. Both will be the mirror image of the one other. But horizontally if we'll cut, you cannot cut equally. That means this is symmetrical about y axis and unsymmetrical about x axis. So once you know the symmetrical either x or y. So suppose y na x bar directly will come 90. That means this 180. See this dividing 90. So an answer is 90. Suppose they are asking only find the center of gravity, x bar directly, no need to calculate x1, x2 and all. But if you calculate nothing wrong, directly you know the answer 90 mm. Then y bar. Y bar you have to substitute all the value. So I already calculated this value will come 76 mm. If we'll calculate this, it will get 76 mm. Okay, so now this is the way of getting the center of gravity. Now how to represent the answer of the center of gravity, you see here. x1 I will represent here. Okay, here x1 individual section of center of gravity. Now x2 y1 then y2 y2. This is the x1 x2 y1 y2. Now what is the final center of gravity? So see here, this line from the y-axis x1 x2 x3, whatever line you will draw in with respect to this, all line will be equal. That means if you know the y bar, we can get the center point. So 76, this is 80, so almost near here. So this is the point, center of gravity. So entire T sections weight will concentrate in this point. If this point is middle point of the T sections, if this T sections will take the fingertip in this point, T sections will get balance. Center of gravity means balance point. Entire weight will act here. So that is called center of gravity. Now we'll find the moment of inertia. So we'll calculate the moment of inertia. It will be very simple now because all the data we have. Only we have to write the formula, we'll substitute the value, we'll get the answer. So before going to the moment of inertia, one simple concept. Individual section moment of inertia we should know. Individual section moment of inertia we should know. So this is the width, this is the height. If I'll calculate Ixx, then this is xx, now this is xx. So what will be the formula? H cube b by 12. I will tell the trick why h cube here, why not b cube. This already derivation is there. Plus 2 students they are studying this derivation, but now our engineering subject they are not asking the derivations and all. So we are not deriving. So we have to remembering the formula. Then Iyy you see na b cube h by 12. Now I will tell the one silly trick. See here. Suppose xx drawing this line, h getting crushed. So you have to give some mercy. So give the support h3. This way you can remember. Y bar, see, b getting crushed. Give some mercy. That means give the power. That is called your support. You given your support. So b cube h by 12. Like this you can remember. So which sections is getting cut or perpendicular to h? H cube. Perpendicular to b, b cube. So simple. Two techniques is how to remember. This up to you only. Now, individual sections moment of inertia we know. Now what is the parallel axis theorem telling? Parallel axis theorem. Parallel axis theorem. Ig plus a h square. What is Ig? Individual section of moment of inertia. A is area of the individual section. H is center of gravity difference. Final minus individual. So if we know this Ig, H1 formula will be there. I will write. So all data we have with us. So let us directly will write first how to find the Ixx. So you will understand better. Ixx, that means we are finding the moment of inertia about the centroidal axis about xx. So what we will write? Two section is there. So x1, x2, we can write x1, then Ix2, x2. Because two section is there. So I wrote Ix1, x1, Ix2, x2. What is Ix1? First you write here. Ig plus a h square plus Ig plus a h square I wrote. Now how will differentiate? This is section 1. So give 1, 1, 1. This is section 2. Give section 2 and 2. Carefully watch. Because this once will complete, it will looks a very big problem. But if you understand the steps, very simple way, you know or not, you can. Automatically problem will get solved. So now this is x. So x. This is Also x, x, x. That means I, x, x you are finding. Section 1, section 2. Now IG1. I told. So this is section 1. What is IG1? Now look here. What is IG1? Draw the horizontal line. What is getting 40 getting crossed? Make the support 40. That means what is 40 cube. Then the other side what is 180 by 12 plus area. Given area 7200 into, I'll write here H1x, nothing but y bar minus y1. H2x, nothing but y bar minus y2. So that means y bar is final center of gravity, y1 is individual section center of gravity, y2 individual section of center of gravity of the second part. So what is y bar here? 76 minus what is y1? 100. Make the square plus, look at here I x2 x2. So this sections now x2 x2, but we are going what is I x2 x2 horizontal. So 80 cube into 60 by 12. Look at again. Suppose the second sections we are taking. Second sections again horizontal. No, xx we are going. Xx na 80 cube 60 by 12 plus area. Now where we'll write. Okay, now x1 x2 value we know directly. We'll keep it here. Okay, we'll write here x1 we got how much? X1 we got 90, x2 we got 90, y1 we got 80 plus 20 100, and y2 we got 40. Y2 we got 40. That only value was there, no? Y1 100, 80, 40. Correct. All are in mm. All are in mm. Okay. So now here area A2 how much? 4800 into y bar minus 76 minus y2 is 40 whole square. If you'll write this, if you'll calculate this, we'll get the moment of inertia. So this is the important part. This why I taken again one more time I'll explain. So if you'll calculate this Ixx, you will get all the value. If you'll calculate Ixx, you will get 13. I already calculated 138.0 mm power 4. This value you will get. If you'll solve, how to solve na? First you solve this part, then solve this part, add, again solve this part, then this part add, then finally you write. It will take another 2 steps, but concept is this only. Okay, now I will write IYY. See this IYY how much simple again. IYY how much simple are this. I am going to rub it. IYY how much simple. See here, similar process. Suppose this you understand now, this now you can IY1 y1 plus IY2 y2, 2 sections irko. Suppose we will study Z section, I sections will increase another one more section. Same procedure, this and one more part. So okay, so once you understand one T sections, you can solve any type of problem, center of gravity or moment of inertia. So write parallel axis theorem. What is Ig plus A h square plus Ig plus A h square. Now section 1 1 1 1. Section 2 give now y, so y, this y, this y, this also y, this also y, this also y. Now value you write. Value will write directly, then write answer. Now you come the IYY. Now see this IYY vertical line. What is getting crossed? 180. 180 cube into 40 by 12. Or you can say reverse of this. Reverse of this. Now this part, right? 7200 into 90 minus 90. Now see here one beautiful answer will come. If you will see this 90 minus 90, what is coming? This one 0. Why 0 coming? Because this is symmetrical about y axis. So x bar, x1, x2 all are 90. So if symmetrical about y axis, IYY, this part will get 0. Directly write the individual section of moment of inertia, add, we'll get the answer. Now next, this reverse. So now see, IYY, vertical na 60 cube, because 60 getting crushed, no? So give the power 60, then 80, the reverse of this, just check it, 12 plus this part again 0, because x bar and x2 will come 90, so we'll get 0. So what we'll get this answer again, IYY, that implies IYY is equal to, that value also I have 208 triple 1 2 3 4 mm power 4. This is the big value. Always moment of inertia, you will get the very big value. Then total moment of inertia. Total moment of inertia is equal to nothing but Ixx plus Iyy. You fill these two add, this value is coming 3476 800 mm power 4. This you are getting final moment of inertia. This you are getting final moment of inertia. So now you look here. If you are going with the process, if you go the book method, it will be looks complicated, but things are same. So if you follow this process, whatever moment of inertia sections will come, you can calculate simple way. So okay, students, thank you.